Hello students, in this video we will understand the concept of binary search, which is a searching technique in data structures. For binary search we require a already sorted array. If the array is not sorted, then the binary search cannot be performed. And the working of binary search is similar to searching in a dictionary, where you just open a page randomly in the middle maybe, and then if the word that you're looking for, the alphabet, the starting alphabet, if it is lesser than the alphabet which you have opened, then you will look in the lower half, and if it is greater than the alphabet which you have opened, then you will look in the right half. So the same principle is followed in the binary search. Let me take a quick array of 5 elements and let us see how the search will be performed. So say I have the array 2, 5, 7, 9 and 11. These are the 5 elements in the array and their indexes are 0, 1, 2, 3 and 4. Now in order to search, suppose I want to search, we will be taking different items that we will be searching for, different numbers that we will be searching for. So the search value that I am looking for, suppose it is 9. I am looking for the number 9. Now what I will do, first of all I will calculate mid. Now the formula for mid is, here 0 is the lower bound of the array in which this particular value is stored, and 4 is the upper bound. So how mid will be calculated? The lower bound plus the upper bound divide by 2. So we will have 0 plus 4 divide by 2. So this will give us the value of 2. So mid is fixed at the value 2. Now what is the value at 2? Suppose this array is named as A, then the value at A of mid, what is that value? It is 7. So what we will check here is 7 equal to the item that we are looking for? So is 7 equal to 9? No, it is not. So we'll say false. Now 7 is less than 9. The item in the array is less than the item that we are looking for. So therefore we have to look in the upper half, that is only in this part of the array we need to search for the element, because this item is lesser than the number that we are searching for, and this is a sorted array. This prior information we already have. So what we will do is, we will fix the lower bound to mid, that is this number which we calculated, mid plus 1. So 2 plus 1 and we will get the value of 3. So this way we are going to reset the lower bound in case the value that we are looking for is larger than the value at the middle. Now again we will calculate the value of mid. Now again we will calculate the value of mid. So now the lower bound is 3 and the upper bound is 4. Both divide by 2 will give us 7 divided by 2, which is 3. This is an integer division, so we always take the floor. We ignore the decimal part of the division. So we get the answer 3 as mid. Now we will look at the element at A of mid, that is A of 3. And what is that element? That element is 9 itself. So we will check 9 is equal to 9. And the answer is yes, we have found the element that we are looking for. Now suppose I am searching for the number 5, or let us search for a number which is not present in the array. So in that case, suppose I am searching for the number 4, because unsuccessful search also we should be able to find how to terminate. Now I am looking for the number 4, and as we can see, this number is not present in the array. So again we will calculate mid. So 0 plus 4, this same thing, first step mid will be same always. So 0 plus 4 divided by 2, we will get the value of 2, and we will compare 7 with 4. Now 4 is less than the value of 7, and therefore we will look in the lower half. For looking in the lower half, the upper bound is updated. And how we set it? We set it to the value of mid that we calculated minus 1. So in this case, the upper bound will update to 1. Again, now we will calculate the value of mid, and we will have 0 plus 1 divided by 2. So we will get the value of 0. So mid is 0. So we will compare 2 with 4. How is 2 related with 4? Now in our case, 2 is lesser, that the element at the middle is lesser. So we will update the lower bound. We will look in the upper half. Upper half among these two elements only, not the whole array. So now this element is discarded. So we will look only at 5. So how we will do this? The lower bound will become, the value of mid is how much? 0. So 0 plus 1, it will become 1. And the lower bound is also 1. The upper bound is also 1. And when we add these two and divide by 2, the mid will also become 1. Now we will compare the element at the middle, which is 5 with 4. And 5 is larger than 4. Therefore, we have to look in the right half. So what will happen? Now the upper bound will become mid minus 1, that is 0. But upper bound will try to become 0 now. But the lower bound is already 1, and which cannot be updated. And therefore, your lower bound will become larger than the upper bound, which is the stopping condition for the binary search. So this way we are going to calculate the binary search. So let me give you the algorithm. Now this is the algorithm for binary search. We are given the array ARR, in which all the elements are there. N is the total number of elements in the array, and item is the value that we are looking for. Now lower bound is 0, upper bound is always n minus 1 if we are starting from 0. And then in the while loop, what we will do, mid is equal to lower bound plus upper bound divided by 2. Now if ARR of mid is less than the item, then update the lower bound. If ARR at mid is more than the item, then update the upper bound. And if it is equal, then we will print that file. We have found the element, and we will break out of the loop. And otherwise, for looping, what condition we will make use of? We will say, we will loop till when? Till when we will continue in the loop? Till the lower bound is less than equal to the upper bound. I hope this video is useful to you. If you like my channel, please subscribe and recommend it to your friends. Thank you very much.